Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin, wassalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi wa sahbihi rasulillahi ajma'in. Amma ba'du. The Honorable Professor Dr. Abu Rahmat MAG as Acting Rector of State Islamic University of North Sumatra. The Honorable Professor Dr. Hasan Asari MA as Vice Rector of Academic and Institutional Affairs. The Honorable Professor Muhammad Syahnan MA as Dean of the Faculty of Science and Technology. The Honorable Vice Deans, Coordinator, Sub-Coordinator, Chairman of the Committee, the keynote speakers, and also presenters and participants of 2nd IQST Tech 2022. Firstly, let's pray and thank unto our God Allah Subhanahu wa Ta'ala, who has been giving us mercies and blessings so we can attend and gather in this event, namely 2nd International Conference on Science Development and Technology 2022, which is held hybridly at the Grand Kanaya Hotel and Zoom meeting. Secondly, all prayers are presented to our Prophet Muhammad Sallallahu Alaihi Wasallam, the greatest leader who has guided us from the darkness to the brightness. Ladies and gentlemen, the first agenda is the opening session by me as Mistress of Ceremony. Let me introduce myself. My name is Raisa Amanda Putri, Lecturer of Information System Department. Now we are going to the second agenda. Deliver our national anthem, Indonesia Raya, and March of State Islamic University of North Sumatra. Honorable of all audience, stand up please.
Jamiatul Islamiyah Al-Hukumiyah Sumatera Al-Syamaliah State Islamic University North Sumatra UI Sumatera Utara Pusat pengembangan ide dan seni berlandaskan Quran dan Sunnah Pancasila Undang-Undang Dasar masyarakat sejahtera bersama Jamiatul Islamiyah Al-Kuwiyah Sumatera di Aisyah State Islamic University Angkatan Sumatera Uin Sumatera Utara Pusat pengembangan intelek dan seni berlandaskan Quran dan Sunnah Pancasila Undang-Undang Dasar 45 menuju masyarakat sejahtera bersama UIN bangkitkan jiwa raga bersama harumkan Sumatera Utara bersama UIN jayakan Indonesia bersama bangun peradaban dunia.
All audiences have a seat, please. Thank you very much. Reciting the Holy Quran and Pray by Zain Ahmad, student of Information System Department. The time and place is yours.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Ya ayyuhalladzina amanu idza qila lakum tafassahu fil majalis إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم وإذا قيل انشزوا فانشزوا يرفع الله وإذا قيل انشزوا فانشزوا يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات تعملون خبير. بسم الله الرحمن الرحيم. فلا أقسم بالخنس الجوار الكنس والليل إذا عسعس والصبح إذا تنفس إنه لقول رسول كريم. فلا أقسم بالخنس الجوار الخنس والليل إذا عسعس والصبح إذا تنفس إنه لقول رسول كريم. صدق الله العظيم. السلام عليكم ورحمة الله وبركاته. Baiklah, sebelum kita memulai acara kita pada hari ini, marilah sama-sama kita berdoa kepada Allah agar nantinya acara kita berjalan dengan lancar dan mendapatkan berkah dari Allah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وأصحابه رسول الله أجمعين. اللهم صل على سيدنا محمد وعلى آل سيدنا محمد. اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهم كما ربونا صغارا ولجدنا ولجداتنا ولأصحابنا ولأصدقائنا ولعلمائنا ولأستاذاتنا ولجميع المسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات إنك على كل شيء Ya Allah, lancarkanlah dan sukseskanlah acara kami ini ya Allah, dengan memohon ridho dan juga karunia-Mu ya Allah. Berkahilah semua langkah dan perbuatan kami, dan jadikanlah itu semua sebagai nilai ibadah kepada kami Allah, dan juga nilai ilmu yang bermanfaat kepada kami. Ya Allah, Engkau yang maha mempersatukan, kami memohon perkuatkanlah persatuan di antara kami. Janganlah Engkau biarkan ada perpecahan di antara kami ya Allah. Kami ingin memperkuat ikatan ukhuwah Islamiyah agar lebih bermanfaat untuk agama, negara dan bangsa ini ya Allah. Ya Allah ya Tuhan kami, kuatkanlah hati kami, iman kami dari godaan syaitan yang terkutuk dan segala perilaku-perilaku yang tercela ya Allah. Jauhkanlah kami dari mara bahaya, dari hawa nafsu yang tidak terkendali. Hindarkanlah kami dari segala penyakit yang ada di muka bumi ini ya Allah. Ya Allah, hanya inilah yang dapat kami berdoa kepadamu ya Allah. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanatan wa fil akhirati hasanatan wa qina adzaban سبحان ربك رب العزة عما يصفون والحمد لله رب العالمين. Assalamualaikum warahmatullahi wabarakatuh.
Opening speech by Chairman of the Committee. Please welcome Mr. Ali Ihwan M.Com.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. Good morning, ladies and gentlemen. Welcome to the second International Conference on Science Development and Technology 2022. The Honorable Professor Dr. Abu Rahmat MAG as Acting Rector of State Islamic University of North Sumatera Utara, the Honorable Professor Dr. Hasan Asari MA as Vice Rector of Academic and Institutional Affairs, State Islamic University of North Sumatra, the Honorable Professor Muhammad Shahnan MA as Dean of the Faculty of Science and Technology, State Islamic University of North Sumatra, the Honorable Vice Dean, Coordinator, Subcoordinator, and all keynote speakers, and also presenter and participants of the second ICOS DTEC 2022. Firstly, let's pray and thanks to our God Allah Subhanahu wa Ta'ala, who has been giving us mercies and blessings so we can attend and gather in this event, namely, and the second International Conference on Science, Development and Technology 2022, which is held hybridly in the Kanaya Hotel and Zoom meeting. Secondly, all prayers are presented to our Prophet Muhammad sallallahu alaihi wasallam, the greatest leader who has guided us from the darkness to the brightness. I thank the all committees who have struggled to prepare for this international conference and all rank of the State Islamic University North Sumatera Utara who have supported this event. So far, there have many lists of participants from within and outside the country. So I would like to thank all the speakers and all participants who have joined this event. And the last, as human, I realize that I can't avoid mistake as the chairman of the committee. I want to apologize if we have many mistakes. Thank you for your kind attention. Let's say, wassalamualaikum warahmatullahi wabarakatuh.
Opening speech by Dean of the Faculty of Science and Technology. Please welcome Professor Dr. Muhammad Syahnan MA.
Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahilladzi awda'a basairina ghashawatal ghiwayah wa nusalli wa nusallimu ala man arsaltahu syahidan wa mubasysyiran wa nadhira wa da'iyan ila Allah bi'idhnihi wa sirajan munira. Wa ba'du, the Honorable Director of the State Islamic University Sumatera Utara Medan, on this occasion represented by the Vice Director on Academic Affairs, the Honorable Professor Hasan Asari MA, the Honorable, the invited speakers, and Alhamdulillah, one of our speakers in here, the Honorable, the Associate Professor Dr. Agung Imaduddin, Master of Engineering, now with us. And also Professor Mustafa Hussein Ali Hassan from the Arab Academy for Science and Technology and Maritime Transport, Alexandria University. I hope this is a very, because of the time gap with Egypt, I hope that we will be with Professor Mustafa later on. And also the Honorable, the Associate Professor Rafika Aliana Rauf from the University of Malaysia, Perlis, Malaysia. The Honorable Vice Deans, the Head of the Department, Coordinator and Sub-Coordinator, and all participants all over the world, because we know that the participant includes from within the country and also from the outside Indonesia. Welcome to the second International Conference on Science and Development and Technology 2022 with the sub-theme Transdisciplinary Paradigm on Environmental Technology. This is the issue that we all know, that second to the COVID-19 issue is the issue of the environment, and this issue has been addressed by the world leaders and also religious leaders and also the non-NGO about the issue on this environment, because we all know that this issue has become an issue that has come to the fore due to the management of the government and also from the society at large. At this juncture, the Faculty of Science and Technology, State Islamic University of Sumatera Utara, Medan, has taken a step to take the vision and mission as the leading in science and technology, environmental technology. So we have already focused on this, and this very occasion, hopefully, from distinguished invited speakers, inshallah, we will share an important issue relating to this environment, especially the question of what are the issues on the environment at this very moment, and what steps are we taking to handle this issue academically and also practically in the society. We hope that these questions will be answered in this very important meeting, in this very important second international conference, because let me share that in the State Islamic University of North Sumatra, WIN Sumatera Utara Medan, has also exercised the paradigm of Wahdatul Ulum, which is the integration not only about the Islamic issues, but also integrated with the non-Islamic issues. I mean, the general approaches popular and also developed in the science and technology. I hope that this occasion will be an important issue for us, and hopefully we can have the merit and the fruitful conference that will give us a benefit not only for the faculty but also for the humanity at large. Finally, we kindly request the Vice Rector to officially open this conference, and for that we thank you, and we thank you all and enjoy the conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Guidance and direction by Vice Rector of Academic and Institutional Affairs of State Islamic University of North Sumatra and open the ICOSD Tech event. Please welcome Professor Dr. Hasan Asari MA.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala ashrafil mursalin wa ala alihi wa sahbihi ajma'in. Wa ba'd, rabbi israh li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Allahumma arzuqna fahman nabiyyin wa hifzal mursalin wa ilhamal malaikatil muqarrabin. وزينا بالعلم والحلم وأكرمنا بالتقوى وجملنا بالعافية برحمتك يا أرحم الراحمين. First of all, I'd like to extend my highest appreciation to the Faculty of Science and Technology for having this second international conference on science development and technology, and of course to the whole committee who has tried to have this happen. Second of all, my appreciations and highest thanks to our invited speakers. We have Professor Mustafa Hussein Ali Hassan of Alexandria, Egypt, and Ms. Rafiqa Aliana from Malaysia, and also Dr. Agung Imaduddin Meng, which is here with us from BRIN, Indonesia. And also my thanks and appreciation to all participants, those who are offline and also who participate online. I'll make this short because much of that need to be said have been said by our Excellence Dean Professor Shahnan. But let me say that this conference is a very important one. A philosopher once said, I couldn't remember where I have read this, science entertains the brain. Science entertains the brain, which is the most important part of ourselves. Technology makes life easier for us. So this is very important because it deals with the very, very essential part of our life. So I think if this is the second, we should hope and we should plan to have the third, the fourth, the fifth, and so on and so on. A conference is very significant and important because in a conference we have ideas, we have thoughts expressed. It is our experience as scholars that sometimes a very small ideas could develop into a potential research. Then we do research and we have some outcomes, be it academics, meaning we have new knowledge and new experience, and be the outcome practical. We devise a new technology which could make our life easier somehow. So a conference which is basically based on oral mode is an opportunity to have many brilliant, perhaps some short and small ideas. Because it takes a much longer time to have your ideas in written form, to have, say, an article published by a Scopus journal. But small ideas can always be very valuable when you remember it once, then when you develop it into good research. Let's hope that we can enjoy this conference very much. And from this conference, we have new research and new findings. With that in mind, I officially open this seminar with Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Next agenda is photo session. Firstly, to all attendees who are present at Grand Kanaya Hotel, please come forward to carry out a photo session. Now to all participants who attended the Zoom meeting, please turn on the camera and give your best smile. Slide 1.
Mendekati satu dari kita.
Next slide. Okay, thank you. Well, ladies and gentlemen, we are going to the core agenda, that is presentation by keynote speaker. Without further ado, I would like to invite on the moderator, Mrs. Rina Widiasari MSE, Lecturer of Mathematics Department, and Muhammad Bayu Azhari SFE, Graduated Student of Biology Department. Then I leave the event to the moderators. Thank you.
Tes. Tes.
Bismillahirrahmanirrahim.
Bismillahirrahmanirrahim.
Thank you to the Master of Ceremony for opening this conference very well.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning, ladies and gentlemen. For the first, the Honorable Professor Dr. Hasan Asari, MA, as Vice Rector of UIN Sumatera Utara Medan, and the Honorable, our keynote speaker, ICUS DTEC 2022, and the Honorable Professor Dr. Muhammad Syahnan MA, as Dean Faculty, Science and Technology UIN Sumatera Utara Medan, and the Honorable Vice Dean, Coordinator and Sub-Coordinator of Faculty, Science and Technology UIN Sumatera Utara Medan, and the Honorable to all the participants, ICUS DTEC 2022. I'm very pleased to welcome all of you to the second International Conference on Science Development and Technology, ICUS DTEC 2022, with the topic Transdisciplinary Paradigm on Environmental Technology. Before we start keynote speaker session, let us introduce ourselves first. As the moderator, my name is Muhammad Bayu Azhari SSE. I'm the alumni Biology Department, Faculty of Science and Technology, State Islamic University of North Sumatera Utara. I will be serving as moderator today for keynote speaker session along with Mrs. Rina.
It's now my pleasure to introduce our keynote speakers. They are Dr. Agung Imamuddin, Master of Engineering from National Research and Innovation Agency, PRIN. Mrs. Rafika Aliana Rauf, PhD from University Malaysia Perlis, Malaysia, and Prof. Mustafa Hussein Ali Hassan from Arab Academy for Science, Technology, and Maritime Transport, Alexandria, Egypt. Ladies and gentlemen, before we begin the presentation of our keynote speaker, I would like to inform some rules in this session. First, each keynote speaker have 30 up to 45 minutes to present the presentation and then continue to question and answer session for 15 minutes. Second, to the participant on Zoom meeting, please mute the voice, and if you have a question, you can raise hand after the presentation or write your question on the comment column during the presentation. Well, ladies and gentlemen, we begin to our first keynote speaker, Dr. Agung Imaduddin, Master of Engineering. But at first, I would like to introduce Mr. Agung's curriculum vitae. Full name, Dr. Agung Imaduddin, Master of Engineering. He was born in Bandung on September 29, 1971, and he is now work at a Research Center for Advanced Materials Indonesia, National Research and Innovation Agency in Indonesia called BRIN. For Mr. Agung education, bachelor degree, he is a student of metallurgy engineering in Iwate University, Japan, and graduate on 1995. For master degree, he also in Iwate University, Japan. He is a student of material science and engineering and graduate on 1997. And in PhD degree also in Iwate University, Japan. He is a student of material science and engineering and graduate on 2001. Well, all participants, please welcome Dr. Agung Imaduddin, Master of Engineering, with the title Research on Superconductors and its Application in Badan Riset dan Inovasi Nasional BRIN Indonesia. For Mr. Dr. Agung Imaduddin, Master of Engineering, time is yours.
Thank you, Mr. Moderator, Mr. Bayu. And Assalamualaikum warahmatullahi wabarakatuh. Good morning, all participants, those who are offline, online, and online attending in this conference. Thank you for having me to be speaker of this wonderful conference. In this session, I will introduce the material that we researched in BRIN. The title is The Research on Superconductors and its Applications in BRIN. I myself is Agung Imaduddin, and I'm a researcher at BRIN. Especially my specialty is on advanced materials. I'm sorry, wait a minute. Sorry. It's okay. Okay, I'm sorry. I will continue my speech. This is my speech title, The Research on Superconductors and its Applications in BRIN. Next. And the contents of, of my today's presentation is like this. First, I would like to talk about the brief introduction of superconductors, and also I want to discuss about our new BMT superconducting wires, followed by BISCO superconducting wires, and then I also want to discuss about the magnesium diboride superconducting wires. These three superconducting was researched in our institution, and also after that I want to discuss about the simulation of electrical and thermal properties of magnesium diboride using quantum espresso and bootstrap. And then I would like to discuss about the research, the project that start this year, that there is the building of superconducting transformer. And then we go to the summary. Okay, next. We have the brief fact about the superconductor. Superconductor is the material that has zero electrical resistivity below its critical temperature. The phenomenon was discovered by this Dutch Heike Kamerling Onnes in 1910. He discovered that mercury under low temperature, the resistance of the material dropped to zero electric resistivity. later this phenomenon was called superconductivity. The reason that the scientists is still very excited about this phenomenon was that the fact that having zero electricity means that the electrical and magnetic energy of the material is never lost because of the zero resistivity. And if you have the loop of superconducting wire, and if we put the electrical current inside the loop, the electrical current will flowing in this loop forever. Next. After the discovery of superconducting material in 1910, it's about 1 century ago, I think. The discovery, there is many material that have been discovered that have superconductivity phenomena. The main material was shown in this chart. As we can see in this chart, the critical temperature of the material increased slowly until 1990. And then the critical temperature increased significantly after the discovery of bismuth, after the discovery of copper oxide superconductor. This copper oxide superconductor critical temperature is higher than the liquid nitrogen boiling point, that are 77 Kelvin. That's why after this discovery of copper oxide superconductor, we enter the era of high TC superconductor. Our arrow that's shown in this chart was the material that available in the market, and the circle material that are niobium tin, visco, and magnesium diboride is the material that we research in our institution. And I want to discuss now. Next. This slide shows the list of superconducting wire that are available in the market. Niobium tin, niobium titanium, magnesium diboride, visco, YBCO, and iron-based superconductor. Especially for niobium titanium and niobium tin, these two materials is commonly used in almost for the superconducting wire that is for such as MRI or CT scan that commonly used in almost big hospital in the world. And also magnesium diboride was discovered around 2001, and now many companies started to develop this material since it has magnesium diboride has the critical temperature higher than niobium tin and niobium titanium, and also magnesium diboride has the low material cost. It is predicted that the magnesium diboride will replace the niobium titanium and niobium tin as the superconducting wire. Next. I'm sorry. This slide. This slide also show the list of superconducting wire that are available in the market. We dealing with the material that's available in the market. We are especially focused on magnesium diboride. In the States, magnesium diboride itself is in the material in the early stage of commercialization. Next. This slide shows the application of superconductor. We can see that superconducting wire have been utilized as foil to produce high magnetic field, such as MRI and maglev or magnetic levitation train. MRI itself has been used at almost big hospitals around the world, and for magnetic levitation train, Japan and China is already utilized this train. Japan has been tested this magnetic train, and China itself has been operating this maglev train in China. The speed of this maglev levitation train can achieve up to 581 kilometers per hour, and this is very high speed for the train. As you can imagine, that the speed is almost close to the speed of airplane. That is 600 or 700 kilometers per hour. That's why if we have this train in Indonesia, we can reach from Jakarta to Surabaya for about 1.5 hours. Next. This slide shows the application of superconductor. When superconductor want to be used, before we select the feed materials, we need to consider the operating temperature and operating magnetic field. The application with operating condition high magnetic field, such as MRI or marimeter or this wine generator, we have to select the material that have good properties on high magnetic field, such as niobium tin, niobium titanium, or magnesium diboride. And for the application with the operation condition in high temperature, such as power cable, FCR, we use high TC superconductor, such as BISCO, YBCO, etc. We in BRIN are dealing with both criteria, which are niobium tin and then magnesium diboride for high field applications, and BISCO for high temperature applications. Today, I also want to discuss about the application of superconductor, that is superconducting transformer. Next. In this part, I would like to mention the little aspect of superconductor, that superconductor have the ability to have effective power energy transport. It means superconductor also have a nature to be environment friendly materials, especially for the field of electrical power. Next. This slide shows the comparison of superconductor and conventional material that being used as a power cable. In theory, it will transport electrical resistivity, electrical transport with 1,000 times larger than conventional ones. That's why these three electrical tower can be replaced by one single superconducting wire underground. That's why this make the using of superconducting cable is very good for environment. Next. It is also the comparison of conventional and superconducting wire to be used as power cable. For conventional power cable, it needs a very big space to cover the heat that emerges from the cable, because conventional power cable have very high temperature. Then we have to prepare the space for the cover of the heat. But for superconducting wire, superconducting power cable, we don't need to have the big space to cover the heat, because there is no heat that emerges from the power cable of superconductor. That's why if you compare them, the superconducting power cable also need the space of 1/50 compared to the conventional superconducting cable. Next. This slide also show the installation of superconducting cables that is installed in US, and also the superconducting magnetic energy storage as application of superconducting cables. Next. I would like to introduce our brief history of research on superconductor in our institution. In 2015, we start to develop the BISCO superconducting pellet, and we have a permanent magnet that was float on the superconducting material. The phenomenon was called the Meissner effect. Then in 2015, we have developed the monofilament wire. We start to develop monofilament wire of BISCO, and also the multi-filament wire of niobium tin. And in 2016, we optimized the synthesization of BISCO monofilament wire, and the image is shown the prototype of our monofilament wire. In 2017, we optimized the synthesization of BISCO monofilament wire, and we start to synthesize the BISCO multi-filament wire. The image shown the prototype of our samples. In 2018, we synthesized the BISCO multi-filament wire, and we start to synthesize magnesium diboride monofilament wires. Next. And 2019, we have the prototype of magnesium diboride multi-filament wire. This multi-filament wire with 3 monofilament wire inside this cable. And in 2020, we have magnesium diboride multi-filament superconducting wire. And we confirm the critical temperature of this multi-filament that was 40 Kelvin. And then in 2021, we have the pellet superconductor of many materials such as BPBO, CuCrO2, FeSETe, LaH10, and others materials. And 2022, we have start to make the prototype of superconducting transformer. Next. I will start with discussion our research on niobium tin superconducting wire. Next. We start dealing with niobium tin in the scope of research with the collaboration with PT Timah. At that time, PT Timah want to utilize its tin production to be the material of the advanced material. That's why they invite us to have this collaboration. The collaboration and also with the collaboration with Lufata, the collaboration in US, we design and we made these multi-filament wires. This cross-sectional image of the prototype, its diameter of around 0.5 millimeters. This multi-filament has 37 monofilaments inside this multi-filament. This multi-filament wire has been tested in Tohoku University for its current density, and the results almost reach the minimum requirement of MRI application. For MRI application, it needs around 600 ampere per millimeter square. In our sample, we have 224 ampere per millimeter seconds. That's why in this prototype, we have to increase the monofilament inside this wire. We need to scale up the process. Next. And then we sinter the multi-filament that manufacture in Lufata, US, and we sinter the multi-filament, and we improve the critical temperature of the wire. The critical temperature, this is the temperature dependence of resistivity. It shows that the critical temperature of the multi-filament has increased from 8 Kelvin to 16 Kelvin. Next. Next, I would like to discuss the synthesization of high TC visco superconducting wires. Next. And this is the synthesization process of the pellet and wires that has been conducted in our institutions. This slide shows the process of visco pellet and also visco wires. We are using powder in tube method, and we use silver as the tube to make these wires. Next. This slide shows the temperature dependence resistivity of visco pellet. It indicates superconducting properties at around 116 Kelvin. It is this value higher than boiling point of liquid nitrogen, and it shows that it can be applied by boiling using liquid nitrogen. Next. We also developed the superconducting wire of visco using silver tube in like this image. We use this tube of silver, and the visco powder was poured inside the tube, and then the tube was rolled and drawing and drawn, and then sinter to make the superconducting wire. Next. This slide shows the cross-section of silver-sheeted visco monofilament wire that has been sintered at 860 degrees Celsius. The left image shows the sintering process for 9 hours, and right image shows the sintering process for 24 hours. The longer sintering time will make the porous or hole inside the cable become larger. And we need to consider this porous in order to get good quality of wires. Hence, we need to repeat the process of rolling, drawing, and sintering for this oxide monofilament wires. These oxide materials has nature that they can be sintered many times, fortunately, but it's going to it also has nature that this material was brittle. That's why we have to handle this material carefully after the sintering process. Next. This slide shows the monofilament wire that we made. Monofilament wires was rolled and sintered. The diameter of this prototype was around 4 millimeter and length was 180 millimeter. This chart shows the temperature dependent resistivity of the samples. It shows this critical temperature of superconducting wire around around onset for 90 Kelvin and TC0 about 70 Kelvin. Next. After we successfully made the monofilament wire, this slide shows the multi-filament wire of visco. We have multi-filament wire that consists of 7 monofilament wire inside the wire. The multi-filament wire was rolled, drawn, and sintered. Then the visco inside monofilament wire is covered by silver, and silver also covered by copper. And the diameter become smaller from 7 millimeter into 4 millimeter. Next. This slide also shows the cross-sectional multi-filament wire using SEM. It shows the morphology of sample visco surface inside the multi-filament wires. Next. This is the temperature dependence resistant result for visco multi-filament wire. Although we can detect the zero resistance, but we can detect the drop of resistance below 100 Kelvin. It shows that our sample was very brittle, and when we roll and drawn the sample, it made the sample the superconductivity properties of sample was broke. Next. I want to discuss the synthesization of magnesium diboride wires. Next. This slide shows the niobium tin and niobium titanium and magnesium diboride on the care of its temperature, magnetic field, and current density. The superconducting properties was brought under three conditions. One is for high temperature, and second for the high current density, and third was for high magnetic field. The current density and magnetic field of these three materials seems not very different, but for the critical temperature of these three, you can see the magnesium diboride has much high critical temperature. This critical temperature property of magnesium diboride has very significant mean for the application of superconductor, because for niobium titanium and niobium tin, we only can get the superconducting properties by using liquid helium that make the operational cost become high. But for magnesium diboride, we can make the magnesium diboride into superconducting properties using the helium gas, and we can expand and compress that helium gas that make the temperature become decrease. Next. This slide shows the synthesis method of magnesium diboride. Actually, this method is similar to visco superconducting material, but for the synthesization of pellet magnesium diboride using we call them powder in shell tube method. That means the powder will pour inside the tube to avoid the oxidations. Next. This is some improvement that we received in this research by adding the carbon nanotube and silicon carbide on magnesium diboride. You can see that after the adding of carbon nanotube by 10%, we have TC0 become increased. And also, when we adding the silicon carbide inside the magnesium diboride, there is shifting of TC0 to be the higher value. Next. This is the magnesium diboride monofilament wire. We made the monofilament wire from a diameter of 4 millimeter to 1.8 millimeter by using the rolling and drawing and sintering process. Next. And this is the results of the monofilament wire. This chart shows the temperature dependent resistivity of the monofilament wire with diameter of 4 millimeter to 1.8 millimeter. You can see that in this chart that with diameter of 4 millimeter, there is no zero resistivity in this plot. Zero resistivity can be detected on the diameter of 3.5 and 3.0 millimeter, and below the 3.0 millimeter, the superconducting properties was broken. That we can see that diameter 3 millimeter has the optimum superconducting properties. This indicates that we assume that the density of the magnesium diboride powder inside the wire have a significant role on this superconducting properties. That's why after this measure, we make the measurement of density effect of magnesium diboride wires. We make these three kind of monofilament wires, so that are low density powder, medium density powder, and high density powder. Although it was not shown in this presentation, but from the result we can confirm that low density powder and high density powder have made no superconducting properties on the monofilament wires. Next. This slide shows the prototype of magnesium diboride multifilament wires with the diameter of 3 millimeter. And from these monofilament wires, we made the multifilament wires. We check the superconducting properties using this chart. This chart shows the temperature dependent resistance of monofilament and multifilament wires. We can confirm the critical temperature of monofilament and multifilament around 40 Kelvin. Next. The development of superconducting wire itself has this roadmap. We only has reached the first step. That is we made multifilament wires of magnesium diboride. After this step, we have to optimize the diameter of the sample. We have to make the multifilament wires that have a diameter of 1 millimeter, and then we have to scale up the multifilament wires. That we have to make these long grade multifilament wires, and then we go to manufacturing process. These three steps is our next project and next homework to be done by collaboration with industries. The multifilament wire itself has market in the world. The superconductor wire market in the world was estimated around $1 billion in 2020, and it will be our market in the future. Next. Next, I want to discuss about the simulation of electrical and thermal properties of magnesium diboride using quantum espresso and ball strap. Quantum espresso is a program, a simulation program to calculate the electron band structure and also density, and also DOS or density of state by using DFT or density functional theory. We are using this program to calculate the electrical and thermal properties of materials. And Boltzmann is a program that using quantum espresso data to simulate the thermal and electrical properties of the material with the Boltzmann formula.
I'm sorry,
Okay,
Mr. Agung.
thanks.
Your time 5 minutes more.
5 minutes more. Okay. This is the method of the quantum espresso. We input the parameter of magnesium diboride crystal. In this case, magnesium diboride has a hexagonal structure. And then next. And this is the result of our simulation of band structure and density of state of electron in the magnesium diboride. The right chart show our results, and the left image show the reference. You can see this is similar result, and also we have density of state of electron that we can get from quantum espresso. Next. Quantum espresso also has feature to have the simulation of charge density inside the unit cell. This one atom is magnesium, and 2 atoms are boron. Charge density is the simulation of the electron, the conductive electron outside the atom, and this similar to experiment result that we can get from this reference. We can see that a charge density was parallel in 1, 0, 0 plane. Next. After we got quantum espresso data, we use this data to get thermal and electrical properties using Bootstrap. This is the result of Bootstrap that we can get. There is several data that we can get from Bootstrap. That were density of state, Seebeck coefficient, conductivity, Hall effect, Hall coefficients, thermal conductivity, specific heat, and magnetic susceptibility. Using this data, we can calculate the thermal electric of this material using power factor and figure of merit using this formula. Next. But in this work, we only use the conductivity to confirm the critical temperature of magnesium diboride. This is the result of Bootstrap that we can confirm that there is resistivity drop around 40 Kelvin. Next. I want to discuss about the application of superconducting wire. Then this is next. This is our project in this year. We plan to construct the superconducting wire design and build the superconducting transformer. Okay, right, next. This is the specification of superconducting transformer that we will design. The capacity is 1 kilovolt ampere. Next. And this is the design of superconducting transformer that we will develop. The coil is consists of primary coil and secondary coil. The coil will be put inside this container. The container will be set with some measurement to detect and to analyze the properties of this transformer. Next. And this is, we also calculate the property of transformer using this modeling application named COMSOL. Next. And we are using the high TC visco superconducting wire. We are using about 150 meter to make this prototype of transformer. Next. And this is the station and the image of our lab when we analyze the performance of the transformer. This is conventional transformer that we are test under liquid nitrogen. Although we are not using superconducting wire, the conventional transformer has been improved using this liquid nitrogen. Next. And this is the reference from another reference. The loss and efficiency of conventional and superconducting transformer. And from this result, we can have the reduction of energy loss that will be 81% if we use superconducting wire, superconducting transformer. Okay. Next. This is the electrical condition in Indonesia. We have a potential of using superconducting technology. Transformer that has been installed in Indonesia about 433,000 units. Next. I want to, lastly, I want to talk about the brain itself. Our brain this year has been was a combine of Ministry of Research and Technology, LIPI, BPPT, Batan, Lapan. We are combined and become one entity, brain. And this brain have many facility and many services related research and technology. The information of the service and the research found that provided by BRIN can be accessed by public using this website. Maybe I hope all participants, if have time, can check and access this website and check the collaboration potential collaboration with BRIN, and also how to find the research found that provided by BRIN. Next. And also, I want to introduce our facility of superconductor. This is the magnetic cryogenic magnet that we are using. This is the instrument that the first in Indonesia, the first installed in Indonesia, the first instrument that can produce very low temperature and high magnetic field. The temperature will be 1.5 kilokelvin and magnetic field will be up to 8 Tesla. If everyone can order this measurement through ELSA BRIN, you can check this website and make your order. Okay, next. This is some fun for calibration research that provided by BRIN or provided by BIN website like RIIM, PKR, PRN, SATEPS, and many more. And you can check it and get the information about it. And if you want, you can contact your colleagues in BRIN and have a discussion about this research fund. Next. And this is the summary of my presentation today. One is BRIN has been involving in research of superconducting materials. Niobium tin, viscose superconducting wire have been fabricated using powder insert method, and it shows superconducting properties on multifilament and monofilament wires. Magnesium diboride superconducting wires have been fabricated using powder insert method, and it shows optimum superconducting properties on diameter of 3 mm. Temperature dependent resistance of magnesium diboride simulation data has been calculated using quantum espresso and ball strap that show the drop around 40 Kelvin. The application of superconducting wire started by the designing and the construction of superconducting transformer have been started this year in 2022. Next. Thank you very much for your time.
Okay, thank you for was Mr. Dr. Agung, and dear all participants, give applause for the great presentation by the Dr. Agung Imaduddin. Thank you. And our next session is question and answer session. So the all participants, if you have a question, you can write on the column commenter of the Zoom, and you can raise on your hand and say your name and your institution. Okay, anyone? There's any question for this room, maybe? Okay, sir.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Halim Daulay from Physics Department with Sumatera Utara Medan. I just want to ask one question, only one question. How is the level of implementation of this superconductor technology in Indonesia? Yeah, maybe is it possible to implement in Indonesia, or is this the cost is high, or yeah? Thank you very much.
Okay, is the question clear, sir?
Thank you, Mr. Abdul Halim. Actually, this is the very important question for us as researchers. That how deep or how to implement our research in industry on our life. But I believe that superconducting technology has very significant role in our life, because maybe today we cannot see the superconductivity phenomenon in our around us, but if we go to hospital, we have MRI scan, and there is superconducting technology. And this technology was very very high. That's very very complicated technology that we have to achieve. That there is many fields that have to collaborate to make the MRI. And the superconducting technology was one of the technology that needed in this MRI technology. If you see the MRI equipment, 80% of the cost of the MRI was the wire price. That's why we need to get the technology how to make and how to manufacture the technology of superconducting wire. For example, in China itself, they start to make the superconducting wire from 1980, I think. They start the development of superconducting wire, and now they are the leading of the production of the superconducting wire. Like sometimes we heard the news about the artificial suns, and sometimes we heard the news of the high room temperature superconductor. That was the phenomena of the superconducting technology. I hope that Indonesia, such as the big countries in the world, have at least this technology to implement in this society. And I hope our research can make the difference and make people realize about this technology, and we start to realize that this superconducting technology is not very difficult to achieve. We can make the superconducting wire by using simple equipment, just by rolling, drawing, and sintering. Maybe ordinary wire company can make this superconducting wire if you teach them the technology how to make the superconducting wire. And for the question of Mr. Abdul Halim about how this superconducting technology is implemented in our life, maybe we in this state in Indonesia, we only buy the technology. We buy MRI. We also hear that the superconducting material can be used to be the sensor for the brain or for the heart. The technology using superconductor technology. The answer is, in the stage we are still in the stage of the buyer of superconductor technology. But we are trying to develop and have the technology how to manufacture superconducting wire. That's my answer. I hope you satisfied with the answer.
Okay, thank you.
Yeah.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. I'm so lucky meet you, Mr. Agung, in Medan again, because I know you're the best person. Okay, I want to ask you, Mr. Agung, about the technical superconducting wires. At this time, what the highest temperature obtained in superconducting research, and what the best dopant for the increase the temperature? Because I want to know about the development about the superconducting. Thank you.
Thank you, Ms. Haryati. Ms. Haryati was my student in our institution back 2017, I think. Yeah. She also researched on superconductor. And about the question about the highest TC superconductor, maybe some of you heard about the room temperature superconductor. The news about how room temperature superconductor around 3 years ago, I think, that was very big news in the research of superconductor. That the superconductor that have critical temperature of room temperature around maybe around 15 degrees Celsius. It was very big news in research on superconductor. But the problem is this material only have superconducting properties under very high pressure. Yeah, that's why when we press the material using diamond around 150 megapascal. It's around what we call it? It's around if there is one millimeter square and maybe 100 ton press in this square. That's the pressure that we have to provide to make a superconducting material in room temperature. Of course, this condition is impossible to be amplified in our daily life, but this phenomena, it has the trigger or the hint for the phenomena of superconductor, because the material that can have the superconductivity around room temperature was like hydrogen, and the material is lanthanum dexahedra, and it pressed using diamond, and this is the this have the impact of the theory of superconductor. And after this discovery, I think we will have the superconducting material that include hydrogen inside the material. Because after this discovery, we can assume that the electron around the hydrogen make a big important role about the superconductor around room temperature. That is the biggest or largest high TC superconductor that we can get recently. And then about the best method to increase the critical temperature of superconductor, it is depend of which material that we have to increase the critical temperature. For the copper oxide superconductor and magnesium diboride superconductor or iron-based superconductor or niobium tin, niobium titanium superconductor, there are several different mechanisms that this material have. Because for copper oxide superconductor, if you want to increase the critical temperature, we have to make the copper oxide layer become we have to make more copper oxide layer for copper oxide superconductor to increase the critical temperature. But for magnesium diboride, we have to make magnesium diboride itself have a good crystal structure or have a good interaction with another with the crystal grain, and this is very important to increase the critical temperature. Like I shown in my presentation, the critical temperature, especially the TC0 of superconducting material, can be increased by using carbon nanotube or using silicon carbide. That was my answer. I hope Ms. Haryati satisfied with the answer. Yeah, thank you.
Well, any question from this room? Okay, to Mr. Ridwan.
Okay, thank you to moderator. I have some question to Mr. Agung.
Yeah.
But as you see in the slide, based on Mr. Agung research, how about the potential of using superconductor material in our society?
Yeah.
As you know, in Mr. Agung's slide, Mr. Agung used that country already implement the superconductor is that country have a low temperature weather. Weather. As we know, in our country is a bit hot in temperature of our weather. So how the potential the superconductor material to implement in our society?
Yeah, thank you for the question, Mr. Ridwan. Yeah, the implementation of superconductor, actually, we do not use the superconductor outside the room. For example, the MRI, the superconducting wire was inside the tube of MRI. That's why there is no effect of the weather outside the room. And also, if we want to implement the superconducting material in our daily life, like what we call the sensor, or I didn't explain the implementation of superconductor using superconducting sensor, but other than superconducting wire, you can use superconducting sensor for the analysis of our brain or our heart, or blood. You can use the superconducting sensor inside the device. That's why the weather will not affect anymore with the implementation of superconducting materials. Yeah, as you can see, our lab actually only using the air conditioner to cool the equipment, and the cryogenic magnet the equipment of very low temperature. Very low temperature that we use to measure the superconducting properties. Yeah, that's why weather will not be big concern about the implementation of superconductor. Okay, thank you.
Thank you, Mr. Agung. So almost all of the semiconductor material is implemented on the device.
Yeah, on device, and also if you want to make like magnet levitation train itself, the superconducting wire was installed inside the train itself. And it's covered by a container that sealed from outside, and yeah, it's very delicate equipment, I think. Yeah.
Okay, thank you, Mr. Agung, for the answer.
Yeah, thank you.
Well, is there any question from this room? Maybe from the participant from Zoom meeting? For the participant from Zoom meeting, you can raise hand or write your question in komentar column. If there is no question from the participant, you can call Mr. Agung from the email, maybe. Yeah. Once again, give a big applause for Mr. Agung.
Thank you.
Wow, what a great presentation and research. In fact, we don't know yet that MRI technology in hospital that can scan our body more specific is one of superconductor implementation. Okay. Well, ladies and gentlemen, our second keynote speaker is Associate Professor Rapika Alianda Arao, PhD, from University Malaysia Perlis. I'm so sorry. We will to give a certificate to Mr. Agung before Ms. Rafika Aliana. The certificate will give by Dean of Faculty of Science and Technology, Universitas Islam Negeri Sumatera Utara. Well, ladies and gentlemen, our second keynote speaker is Associate Professor Rafika Aliana Arauf, PhD, from University Malaysia Perlis. Rafika Aliana Arauf obtained her first degree in electronics engineering from Multimedia University, Cyberjaya, Malaysia, with honors majoring in computer engineering and graduated in 2002. She received the Masters of Science in Intelligent Knowledge-Based System in 2003 from University Utara Malaysia, Sintok, Malaysia. Her PhD was obtained in 2014 from University Malaysia with in microbiological image diagnosis and artificial intelligence. Dr. Rafika Aliana is currently working as a senior lecturer at Faculty of Electronic Engineering Technology, University Malaysia Perlis. Her research interests include medical diagnostic system, intelligent system, physiologic, and embedded system. Her topic in this conference is automated diagnosis system with image processing technique for disease detection. Wow, what an interesting topic that collaborate on biology and computer system. Please welcome Ms. Rafika Aliana Arauf. Time is yours.
Can everyone hear me over the Zoom meeting? Sorry. Okay, alright. Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh, and greeting from Perlis, Malaysia. Thank you, fellow moderators, Ms. Bayu and Ms. Rina, for a very warm welcome and introduction. The honorable guests of the day, Professor Dr. Hasan Asari, the Vice Rector of State Islamic University of North Sumatra, Professor Dr. Muhammad Shahnan, the Dean of the Faculty of Science and Technology of the University, Mr. Ali Ekwan, the Chairman of the conference, the other fellow keynote speakers, Dr. Agung Imaduddin, and also Prof. Mustafa Hussein. Thank you very much actually for inviting and giving me the opportunity to share my research work and maybe open the possibility of future collaboration between State Islamic University of North Sumatra and Medan. Okay, I think I will leave the presentation to the Medan to share the screen of the presentation. Possible because
Wait a moment, please. Wait a moment, please. Miss Rafika.
Okay, so here we go. As mentioned by the moderator just now, Ms. Rina, this is my title for today, Automated Diagnostic System with Image Processing Technique meant for disease detection. Okay, I'm Rafika Aliana, a PhD holder in computer engineering field. Currently, I'm associate professor in the Faculty of Electronic Engineering and Technology. And in the meantime, I'm also the Deputy Director in the Center of Graduate Studies in IMAT. So that is my email should you want to reach me through the email. Okay, next slide please. Okay, let me introduce you to UNIMAT first. Maybe some of you have come to UNIMAT before. If you have not, then welcome. Please do come to Perlis, a small state in the Peninsula Malaysia, the north of Peninsula Malaysia. So that building is our faculty, namely the Faculty of Electronic Engineering and Technology. Okay, next. So actually in Perlis, we have multiple campuses of UNIMAT. We have actually 3 campuses. One is in Padang Besar near the border of Thailand, and another one is the Power Putra campus. This is where I'm residing now, the main campus, the Power Putra one. And we have another one in Kanaya. So that one is the center of Perlis actually. Okay, so we have 3 campuses, so we travel a lot in between these campuses throughout the state. It's not a very big state, but it sure give a very good traveling between these campuses. So please come and I'll bring you along to all these campuses when you come here later. Next. So these are some of the view of our campus, the main gate of UNIMAT, University Malaysia Perlis, and our scenery. So we have we are surrounded scenery of in-campus trees. Okay, next. Alright, so I'm going to talk about my research work. So this is the research that I have been working on since 2008. Okay, but back then I start with one disease, which is the first one. So in overall, we are working on image processing field and incorporating the intelligence system with artificial intelligence technique. So there are multiple projects that we have been working on. Some of them are like what I've been shown in this slide, automated intelligent diagnostic system for tuberculosis disease, or we call it TB, and we detect it based on multiple specimen, but I'm going to show here which is the one based on sputum specimen prepared using the Ziehl-Neelsen technique. Okay, we also have research on segmentation technique, which is also image processing. For nucleus detection, we want to detect the nucleus part in the blood images. So in blood images, it is for detecting the disease of leukemia. And we also do image processing and classification research for malaria and brain tumor. So we work hand in hand with some of the university hospital here in Malaysia. We have the HUSHAM in Kelantan, and we also have some expertise from the hospital to provide us with the data. We provided with the specimen from the patient, and then we proceed with the research. So for today, I'm going to focus on the first title here, colored in yellow, the Automated Intelligent Diagnostic System for TB, tuberculosis. Okay, next. Alright, so this is basically the raw outline of my speech today. I'm going to give you some introduction about the disease, how we do the image processing technique to actually process the raw image given by the hospital, and also how we proceed to develop the automated intelligence system to actually do the diagnosis for that particular disease. Okay, next. Alright, for some introduction, I bet most of us have heard about the tuberculosis, or we call it TB. Okay, actually TB remains the most important infectious disease in the world even until now. I'm sorry that the statistic is a bit off. This actually happened in Asia, as where we are now. We are in Asia, and mostly come from our place. Okay, this part of the world in Asia. And there's also in Africa, Eastern Mediterranean region, also other parts of the world, but mostly it's in Asia. So that's why the focus of finding the way to help the medical practitioners from us, the engineering side, how can we help the community in actually combating this disease. Okay, next. So what is TB actually? How can we get TB? Actually, it's an infectious disease caused by some common called MTB, Mycobacterium tuberculosis. So this is the Mycobacterium tuberculosis is spread through the air. So that's why when you go to a hospital, when someone is contracting a TB, they isolated them in a separate ward, so they cannot meet any other person, because we don't want it to spread the bacteria through the air. Because when the TB patient cough or sneeze, then they will spread the bacterium to the other person. That's close contact. Usually, TB bacilli will affect the lung, but it can also affect other part of the body. For example, the bone, brain, kidney, and other organs inside the human body as well. Okay, next. So there are two types in general, two types of TB, tuberculosis. The first one is the pulmonary tuberculosis, we call it PTB, and this is the most common one lah. Okay, what is pulmonary tuberculosis? It is where the MTB, the Mycobacterium tuberculosis just now, were found inside the lung of the human, our paru-paru, the lung, right? So the way to diagnose whether a patient is contracting this pulmonary TB or not is by screening their sputum. They are going to give the sample of sputum to the medical practitioner. They will do some specimen and they will diagnose under the microscope, see whether there are TB bacilli within that sputum image or not. The other way is to do X-ray images, so we can see inside the lung the way that the X-ray appear, and we can see whether that patient is having TB or not. Another one is extrapulmonary TB. It is EPTB. This is the one that is happening outside the lung, where we can see that it's coming from other organs that I mentioned just now, the bone, even the organs, right? But most of the time, for EPTB, this is happening to the HIV patient. Okay, it's very rare among common people. Common people will usually contract pulmonary TB. So we do both, but we focus more on the pulmonary TB since that's the most cases that's contracting in Malaysia. Okay, next. So in order to make you understand how do you diagnose TB in the hospital, okay, in the mostly commonly used method here is that by direction of direct smear, where the patient gives the sample of the sputum, and then the medical practitioner do the staining using the Zell-Nielsen method. There are some chemical staining there, and they will have a specimen. Okay, when they have the specimen, they will place the specimen under the light microscope. Then the technologists will look through the lens of the light microscope, and they will do the manual slide reading. Manual slide reading means they are going to look through it by the trained technologists, and they will count the number of the TB bacilli existing within that particular microscopic image. But the thing is that the technologists will need to go through 300 of the what do you call microscopic view. That's a lot. So if you were to look through the microscope, it will be the strain to the eye. So that's the problem. And also the visualization is made under 100x using the light microscope and using all immersion. So the afterwards the technologists will provide an estimation of how many of the number of the bacilli detected in that particular specimen after viewing for such amount of microscopic field. Okay, that's a lot of like we know that human tends to feel tired throughout the day. So the objective is to give them some way of assist so that we can counter this issue. Okay, all right, next. So the benefit of the automated diagnosis system is that we hope that it will give greater accuracy in diagnosis, increase in the volume of slide that can be screened throughout the day, and also the automation of the diagnostic process can reduce the eye strain in the laboratory staff, especially the technologists and the microbiologists. Of course, we do not mean for this to replace the human. No, we don't mean for the research work to replace the human to do the diagnosis. We just expect this system to actually assist them in a much comfortable way so that they can do their job better throughout the day. Okay, next. So in order to design such a system, there are two parts. Okay, there are two parts actually. The first one is by implementing image processing technique. And these are a very basic image processing technique that will usually be used in any process. Okay, the first one will be image acquisition, where we'll get the image from some source. Some of us take it from the database of the website available in the internet. But for our side, we acquire the data from hospital. We have the collaboration with the hospital. The hospital provides us with some real specimen from the patient, and we retrieve the images from that particular specimen. And next step are the image enhancement, where we do some enhancement on the captured image so that it's clearer, better, and easier to be processed on the later stage. So the next part is the image segmentation. In image segmentation, what we do is actually we want to retrieve the object of interest. Later, I'll show you the image of the raw image of a TB bacilli, and we can see which are the object of interest and which are the non-object of interest. So we are going to get rid of the background. We are going to get rid of some other cells that is not going to meant for to be counted in the TB bacilli process. Okay, and last but not least are the noise filtering to remove all the noise using the media filter and some other filter existing. All right, next. Okay, so this is the image capturing setup that we have here in the university. So to the left, we have the desktop station, the computer, where we connect the computer to the light microscope, which is to the left. We have this microscope. This is just a light microscope and not a fluorescent microscope. But we also have the SDK. We have the motorized stage. What we call the black one is the motorized stage, where it can be moved according to the computer program. So we design a program so that the stage can move automatically. So when we place the specimen on top under the microscope and we click start, then we can see that the image will be captured automatically from left to right and go to the next row and such. Okay, and then on top of the on top of the light microscope, we have the digital camera. The digital camera is placed there so that it can capture whatever that we see through the lens. So the digital camera will proceed to bring that particular image to the computer. So everyone can see it through the computer now, and you do not need to look through the lens anymore. So that in one purpose can already reduce the eye strain of the technologists and microbiologists. So they can now rely on the computer rather than looking on the lens of the microscope. So this is the image capturing setup for almost all microbiological sample that we have. We do this for the leukemia sample and also malaria sample and even the brain tumor, astrocytoma sample. Okay, next. Okay, so this is the sample of the raw image, the original image, when we captured the smear microscopy based on the Ziehl-Neelsen technique where the microbiologists prepare for us. So you can see here, these are 4 images, 4 original images, and if you can see the red bacilli in rod shape, so those are the TB bacilli. Those are the object of interest that we want to count. We want to count how many of that existing within one image. So this is just 4 images. Imagine that they need to count up to like what, 300 images. That'll be a lot of work, right? So that's our task, to help them, to provide them with good images, with clearer images, so that they can do the counting correctly. Okay, next. Okay, from the slide, which is prepared manually by human, by the technologists, of course there are some problems. Okay. Sometimes when you do the preparation of the slide, the sputum smear is not of the same thickness. From one end to another, sometimes there are thin and thick sputum. So when that happens, when you look under the microscope, you will see a different presentation of images. For the thick sputum, you will not see it clearly. You will see as if there are too much of a blue background because of the sputum is very thick at that particular end. But towards the thinner end, you will see too bright because of very thin of smearing. So that's why we have the problem with the slide of uneven smearing. So that one needs to be combated. And also overstain specimen, where you put too much of the chemical over the specimen, and also this will result in poor image when you view it through the PC screen. Okay, and the solution to this, of course, is to do image enhancement technique, so that we can actually make every what we call image in a standard view. Right? Next. All right. So this is example. We implement white balance. Okay. If you look through the left image, the white balance is the image of the original image is quite bluish. Okay. So we can hardly see any red bacilli in there. So when we do a white balance, it's like moving the histogram to the right, towards the white part. So we can like remove the bluish element from the original image, and we can get a clearer image as the output image. So later we can see better image with red bacilli over there in output image. So this is one of the technique that we use of the white balance in doing the image enhancement. Okay, next. Okay, whenever we do any program, any algorithm, we are also going to look at the histogram. Okay, to the left of this one, the original histogram. I mean, from the original image just now, we can see. Okay, one more thing is that we are working on the color image. Color image is a bit tricky because we have 3 planes. It's either RGB, red, green, blue, or maybe LAB or HSB, but it's more complicated as compared to binary or grayscale image, where we only have one plane ranging from the value of intensity 0 to 255. But when we have color images, then you need to consider all the planes to be processed. So that will require a higher computational complexity as well. Okay? So if you look from this histogram, the difference between the left-hand side and the right-hand side is that the right-hand side has been gone through the white balance. You can see that the histogram is now moving or shifting towards the left. Okay? So the red color is representing the red component. I'm taking the example of red and green component in this particular image. So they are shifting to the 255 value, which means we are making it clearer, making it towards the white element, so that we can actually eliminate the blue element that hide the TB bacilli from our side just now. Okay, all right, next. And next, Another method that we try to use is the partial contrast. Partial contrast is actually from the histogram just now we do some compressing and stretching of a process. So some element or some what do we call object of interest within the image, we don't want it. So we try to compress it so that it doesn't actually appear that important within our output image. But for those of object of interest, we try to stretch it so that we know that this is the part that we want to look further into it. So here are some of the equations that we use and for the partial contrast, and you can see the result in the next image. Next slide. Okay. So we can see here, the original image to the left, it's quite blurry. If you really see it, it's hard to differentiate whether is it really red or not. But when you bring it through the partial contrast algorithm, you can see the difference, especially the lower part to the right. Okay, so that's a modified partial contrast that we implemented. You can see that the image of the TB bacilli become brighter. I mean, redder in terms of reddish. So you know that, okay, this is confirmed, this is a TB bacilli. As opposed, if you look to the original image, you need to guess, is it yes, is it a TB bacilli or is it not? So with the help of this technology, of this algorithm, we can actually bring it to process and we can emphasize which part is the real TB bacilli or not. And hence, it makes easier for the technologies to count it towards the end of the diagnosis. Okay, next slide, please. Okay, this is another example. If you look from the left, it's very hard. You can hardly see. There's no red element at all. But when you go through the modified PC algorithm, we can see that the red bacilli are being highlighted and it's easier for the doctors to actually diagnose. Okay, next. Okay, again, even weirder images, but these are the examples of how the result of the partial contrast and image processing can really help us in, to help the people in medical field to do their work by using our engineering knowledge. All right. Okay, next. Yeah, next as well. Another next. Okay. All right. So previously, histogram is just using white balance. Now this is the result of histogram, the same histogram just now, but this is when we went through the partial contrast. The partial contrast will stretch the middle part of the histogram, in which those are the part with the most significant information. So we want them to be really emphasized so that we know that the information can really be highlighted so we can appreciate that part further. Right? So you can see the difference between the left histogram and the right histogram, where the result of the output, you will get more information scattered throughout the intensity level from 0 to 255. Okay, next. Right, so the next part, that's about the, previously is about the image enhancement, making the image to appear better as opposed to the original image. So the next segment is about segmentation. Okay, segmentation is about throwing out of whatever pixels that we don't have. So there are many methods of image segmentation, but these are among the most popular one and still being used, where you use the OTSU color thresholding, k-mean clustering, moving k-means, and also fuzzy c-means to work throughout our microscopic images. Okay, next. Alright, this is examples of OTSU method, fixed value color thresholding for RGB. As I mentioned just now, for RGB images, for color images, we will need to do it layer by layer. So we have red layer, green layer, and blue layer, and we need to do it one by one in order to make sure that we are implementing the rules to all of the layer. Right? Next. Okay, so this is the result, where you can see the original image is a bluish background with reddish TB bacilli. The reference image down there is an image where we have cleaned it manually. We delete the pixel manually using some Photoshop software, and we try to map whatever result that we have using our method to that particular reference image and see the accuracy that we get. So by experimenting, we can see that those are the results from the right hand side. We can see that they appear that way. we are able to eliminate the background with some noises still there, the salt and pepper noises, and sometimes there are huge object noise as well, with the accuracy of up to 90, I think 99% there. Okay, so that's a very good result for us lah. Okay, next. Okay, after we are done with the segmentation, this is the part where we do the automated intelligence system. Okay, for the first part where the slide preparation that is prepared by the hospital person, the one that we have collaboration with, and then we do the put the specimen under our microscope using the setup that I've shown you just now, and then we come up with the image processing technique using the image enhancement, image segmentation, and also the noise filtering, and then it will come up with a system where it will give you the number of TB bacilli that have been counted within each images and also within each of the specimen. Okay, next. Alright, so this is the step-by-step of the intelligence system that has been developed here. From the original image, this is the example of only one image lah. Okay, we have original image, then we brought it through image enhancement, then the structure change, then we have color thresholding, then we remove the background, we retain only the TB bacilli, and then we do the filtering where we remove all the noises, and then we do feature extraction in order to make it into the intelligent classification. So the feature will be about the color of the object, okay, and also the shape of the object, because we want it to detect an object with the shape of a rod, a bacilli of a rod. Okay, sometimes we get the noise in terms of a circle, so we want to remove it and know that that one is not the object of interest of us. Okay, we don't want it to be counted. So if you look to the far down left, you can see that the number of TB bacilli being counted is 3. So looking at the image, then that is a correct result lah. There's 3 bacilli, so that 3 will be accumulated with some 300 images. So the microscope will move its motorized stage throughout the specimen and capture 300 images and do this thing over and over again. And the number of TB bacilli will be accumulated until the end of the way of the specimen. So at the end of the process, you will get the total number of TB bacilli within one specimen for one patient. So that's when we classify the severity of that patient. The more TB bacilli detected, that means the more severe that the patient is inside that particular, within that particular disease. If there's no TB bacilli at all, then we can say that this patient have a negative, with no more TB disease. That's how they put it. Alright. Okay, next. Okay, I think this is a recurrent setup. Again, the same thing like just now, the computer, the camera, and the microscope. Okay, next. Okay, this is how the sputum slide is being classified by using WHO classification. Okay, we always refer to WHO to do the classification. So there are category of the slide. That's how they categorize the patient as well. Heavily positive, strongly positive, moderately positive, weakly positive, and negative. Negative means they are free from the disease. There's not even a single bacilli from the disease. So these are the number of specimen that we have, 60, 50 specimen, and the total number of slide that we have is the most for the hardly positive, and the classification is like 47 of them are correct. The most hardest part is to actually detecting the negative one, because we always get that, when we measure this, we measure into the accuracy, specificity, and also sensitivity of the calculation, whether we have true negative or true positive, false negative, and false positive. So all that is being taken into account, and we get that when reporting our result. Okay, next slide. Alright, so this is another project that we did, just to show you some other project. Previously, we've talked about the tuberculosis disease, and this is the same process, but the algorithm and the parameter will be a little bit different because of the different input image. This is for detecting leukemia. we are getting the blood samples from the hospital, and it can be used to actually detect whether that patient is having that leukemia or not. Okay, so for blood image for leukemia, this is how we do it as well. The same process, starting from the image position, acquiring it using microscope, and then we get the microscopic image, then we do image enhancement, and then image segmentation, until the end that we get to really look into the nucleus of that blood sample, of the blood cell. Same goes with the malaria and also the brain tumor, where we are now working with the astrocytoma of brain tumor disease. Okay, next. Alright, so these are the ongoing research that we are still having. I'm having students working on this as well. So we have astrocytoma diagnosis. This is what I mentioned just now about the brain tumor. Again, we always have collaboration with the hospitals. I believe you have a lot of opportunities working with hospitals in Indonesia as well. We incorporated deep learning, that now deep learning is becoming more common in our intelligence systems, and also we're looking on implementing them in FPGA. Okay, FPGA is becoming more popular now, where we can do in parallel processing. So we have worked with Intel to actually make this work of implementing these algorithms, especially image processing, because we know that image and video processing is consuming a lot of computational job, and we need a very good machine to do it. So we are working with Intel for that. So that's what we are doing now, and to the future work lah. Okay, next. Okay. So I think that will be everything about my research. So I want to show you what we have here in FK10, my faculty. We have a diploma program, bachelor program, and also postgraduate. So we welcome you, come and also make some collaboration maybe. We have master by mixed mode, master by coursework, and also PhD in our faculty. And maybe we can see from the next slide. Next slide, please. Yeah, these are some of other UNIMAP postgraduate program. Overall, we have also the civil engineering, chemical engineering, and also electrical. There's a lot of programs, so that we can do collaboration, actually, joint degree and all, and maybe even dual degree. Okay, so for the next slide, maybe we can see that what are the potential collaboration that we can see. From the next slide, please. Okay, just showing that UNIMAP is currently have a 5-star ranking, and we are looking forward to more collaboration with the international university. Okay, next. Okay, these are the more ranking, okay, of the UNIMAP and also the faculty that we get from this year. Next. All right, so these are the one that I want to emphasize, actually, because I'm very grateful that for the invitation that we have. So I'm looking forward to join activities with academia, especially with North Sumatera State Islamic University. Maybe you can do a joint degree, maybe we can do the inbound or outbound mobility, co-supervision between the university, and also, being alternate examiner for each other, and also joint research and publication. So it's a very good potential collaboration that we have here, actually. All right. Okay, next. Okay, so this is the same. We are working with the industry as well, because I think it's the same with Indonesia, that we need to really collaborate with the industry in order to make whatever our research are being commercialized. We want to actually contribute back to the community. So having collaboration with the industry is very important as well. Okay, next. All right, so this is the CGS, the postgraduate school that I'm working now. So welcome. If you want to do collaboration, we welcome you to contact us. You can contact us by visiting the website and also the QR code. I think that will be my last slide, I think. Next slide, please. All right, thank you. So that's the end of my presentation. Thank you very much for listening, for lending your ears throughout the hour. And it's very intriguing to see the presentation by the previous keynote speaker just now, even though it's not my area, but I'm very happy to see some other researchers are doing. All right. Thank you.
Okay, thank you for Miss Rafika. Okay, the all participant give applause for Miss Rafika. All right. Thank you for Miss Rafika for the next. Our session is question and answer session. For the all participant, if you have question, please raise your hand or write on the comment column Zoom meeting and say your name and your institution. Okay. All right. Okay.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. I have one question. Why the choice of the K-means algorithm as solution in the research, Mrs. Prof. Rafika? Because now I had a research ongoing deep learning with CNN. Can you advise with me because about my research? Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for the question. That is a very important question now, because we know that deep learning is having a very vast popularity now, right? Especially in the crowd of artificial intelligence, which is correct. You are going in the right direction. Congratulations. Okay, so when we talk about deep learning, there's a lot of possibilities yet to explore. I certainly agree with you that there are still a lot of things that we can explore about deep learning. K-means clustering is only the introduction part of it. Last time we used a lot of K-means clustering, right? For normal images where we can actually separate them instantly. What I mean is that if the image is not that difficult to be segmented, then we can use simple algorithm. For example, also thresholding, maybe K-means clustering and other technique of clustering. But when we come now, especially when the technology is become very vast now, we have high computational power. So we can make use of deep learning knowledge. So that I agree with you. Please proceed with deep learning research. We can even make collaboration. I'm also working on it with my current student now. Okay, there's a lot of potential that you can actually skip the image processing. You don't need to do image processing of step-by-step image enhancement, image segmentation. You can directly replace it by using deep learning. But one thing is that deep learning, as we can see in the website, also when we look at it, deep learning will need to have a lot of data. A lot of data is needed to make it work in a very accurate manner. So that's the problem that we have in medical diagnosis. Because in medical diagnosis, a lot of data means a lot of patient. we don't want to hope for more patients to come. Please help more people get sick so we can have more data. So that's the tolerable thing that we need to cater in between having the medical data, because of course having more data is good, but we also have that ethical issues and everything, so that we can process the data more, right? So work toward it is also about how do we deal with what do we call insufficient data. So if you have small data and we want to make deep learning work, how do we do it? So that's also a very good topic, especially in medical field lah, where we don't have enough data. If you just want to scan through buses or cars or even trees, there's a lot of cars, there's a lot of buses out there where you can snap the picture and you put it into your database. But for medical, you will need to, put in thousands of images as your trained database, so that it can produce a good accuracy and sensitivity and specificity. So that's the challenge that we have now. And that also is what we are working about in deep learning. I agree. I certainly agree with you that deep learning is the way to go for now. Right? I hope I answer your question.
answer is clear? Okay. Okay, to our participants, does anyone have a question for the Zoom meeting for this round? Okay, from the Zoom meeting. Okay, for Miss Aninda Mulyani. Okay.
Thank you very much. Good afternoon, Miss. I want to ask, does this technology support to be developed to extended reality, or we know that extended reality is the combine of virtual reality and augmented reality, and if it's possible, what is the obstacle? Thank you.
Okay, thank you very much for the question. All right, for my focus, my research work, we deal a lot with microscopic images. So that will be a little bit hard for us to venture into this particular field. But I know that it's going very vastly as well, the virtual reality and augmented reality. Okay, I have friends working on it, but it will go not into the microscopic image prediction. Maybe it will go to some other diagnostic parts where we deal with the, having the surgeon to be trained, how do they make a surgery. Then we have some people of that in our faculty as well who work on it. They train the surgeon by using, they develop the surgery procedure using the VR, using the virtual reality, so that they can try to practice on performing the surgery on a virtual patient, whereas the patient is not really there. So it's a good training so that the surgeon can have a very multiple skills without having the real patient. Because sometimes, which is true with the era of digitalization now, we have a lot of things coming with a good processor, with good memory in the technology of electronic engineering. Many things are coming. Okay, from that perspective of medical work, I certainly agree that the extended reality combining VR and AR is a good choice of research focus as well. And yes, we have that side, that group of working on it, but I'm not into it. I'm focusing on the microscopic images, but it's good for you. Please come to UNIMED and we can make a collaboration later. I can bring you to the group who work about it.
Okay, thank you.
Okay, thank you.
All right. Thank you for Miss Rafika and Miss Aninda for the question. All right, for the next question, does anyone have question? Okay, if not the question, maybe for the moderator, Miss Rafika, I have a question for you, maybe. Actually,
Sure.
Your research is very interesting for me because I'm from bio department and my research about the biomedical. So I had a question for you, Miss Rafika. Miss Rafika, is the image processing in your research can diagnose in kidney histology? Because my research is about the kidney histology, and or maybe the other histology organ. Thank you, Miss Rafika.
Well, actually, there are many. If you look into medical research, there are many prospects and many forms of medical research. Some of us work on for example, when I talked about tuberculosis just now, some people are working on the X-ray images, right? So the way that we do image processing on X-ray images are a little bit different, even though that we still do images. Okay, so I believe that for the kidney diagnosis, you have some way of diagnosing it. The way that we do things is we go to the practitioners, the medical practitioners, in the hospitals usually, and ask them how do they do their diagnosis, right? So in order for us to contribute back to the community, so that's what we do, right? We Muslim try to help each other. So that's what academia do. We don't just read for us to be genius. We want to contribute back. So we ask them, what can we help you with? So if they provide us, okay, this is how we do things in hospitals, and then they will have their own problem and they can give us the problem statement. Okay, we are having this problem, like this diagnosis is hard to be done. Can you contribute something? Can you contribute a knowledge in electronic engineering, in communication engineering, maybe, where you can build some maybe antenna or some device to actually measure some ultrasound or wavelength to actually detect the disease. That could be done. That is a very good research as well. So that's a lot. And we have biosensors and all those particular things. So the most important thing is to see in which part of the medical diagnosis that you fit in. Then you go into it and look into the possibility. If the kidney diagnosis of cytology is using image processing, I think it can be done as well. Okay, most of the time we have all the diagnosis within the image processing, they are almost the same. So I believe yes, we can implement the same basic flow to the kidney physiology as well.
Okay, thank you for Miss Rafika. It's very interesting for me. I hope for next time we can collaborate maybe for the next research.
Yeah, sure.
I
Please
hope,
email
I
me.
hope. Okay, thank you, Miss Rafika, for the answer, and to all the participants. Thank you so much for your great presentation. And maybe there's nothing a question. And maybe thank you so much for Miss Rafika for this opportunity. Thank you. And for maybe we can continue for our next keynote speaker, the last our keynote speaker. All right. Certificate. Okay. Maybe we can continue for our next keynote speaker. And all participants. Our keynote speaker is Professor Mustafa Hussein Ali Hassan. Prophet. Sorry. Professor Mustafa Ali Hassan was born in 1953 in Alexandria, Egypt. He received his Bachelor of Science, Master of Science and PhD from Faculty of Engineering, Alexandria University, Alexandria, Egypt, respectively in 1976. 1983 and 1987. He is a professor of optical communications, electronic and communication, engineering department, College of Engineering and Technology, Arab Academy for Science, Technology and Maritime Transport, Alexandria, Egypt. He completes the supervision of more than 150 Master of Science and PhD student and publishes more than 360 journal and conference paper. He was external examiner for more than 170 Master of Science and PhD student in Egypt, France, Canada, India, and Malaysia. His research include optical communication, optical amplifiers, free space optic, visible light communication and optical network. So for our keynote speaker, Professor Mustafa Hussein Ali Hassan, times is yours. Sorry, Prof. Please unmute. Hello, Prof.
بسم الله الرحمن الرحيم. السلام عليكم. السلام عليكم.
Waalaikumsalam warahmatullahi wabarakatuh.
First, I thank you very much for this invitation. It is my honor and pleasure After few slides, I will use some videos. So I am co-host, I think. You have the presentation, but I have the videos. So when I ask, please make me co-host to share some videos. Next, please. This is the title of the presentation, New Era in Optical Communications. Next. This is me. I think you introduced me correctly. I am from Alexandria, Egypt. Next. The important questions or question is why we go to optical communications. You know, in our life now, without optical communications, nothing will happen. I will show you that 99% of the communications in the world now is using optical communications. You know the internet, for example. 10 years ago, we just sent some messages, then images, then videos, then YouTube, long time films, and so on. The huge bandwidth needed cannot be achieved without optical communications. Next. The following are some statistics of using the internet all over the world. I think the resolution is not good, but you can have the presentation. I can send you again, or you can share from the head of the conference. Next. This is also another statistics of using the internet, very, very huge bandwidth that cannot be achieved again without optical communications. Next. Also, it is a statistics. Next. Another statistics up to this year. Next. Next. All these are statistics. This is an example of the undersea cables using optical fibers and optical communications. The length of the cables is millions of kilometers, millions undersea. I will show you a small video for 2 minutes to illustrate this. Next. This is one example called flag fiber optic link around the globe. It was installed in 1994 and its length is 26,000 kilometers. It has 13 land stations. 2 of them are in Egypt. Why Egypt? Because we have a port in Mediterranean Sea and another in the Red Sea. So the cable passes with the Mediterranean, then Suez Canal, then the Red Sea to India and so on. Next. This is the newest one, CME 3. Its length is 43,000 kilometers undersea. 43,000 kilometers undersea. Next. This is the first video. You see it? I shared it.
Yes, sir. Yes, sir.
Do you see it?
Yes, sir. Yes, sir. I see. You see it. And the process.
Do you see the video?
Yes. We'll see your videos and the process.
Sorry, nothing video here. Okay.
See this information, 99% are optical communications. Please return to the presentation. Next. No. Return back, please. Yes. What is optical communications from the beginning? It is a type of communications, but the difference is only the carrier. The carrier is light, and the frequency of the carrier is tens, terahertz. And according to Shannon equation, as the frequency increases, the carrying capacity increases. So using light is very important to carry more information. But the question is, why it is late? Why it is late? Next. As a definition, we say light is an electromagnetic wave with a certain frequency, but the word optics is more general than the word of light, because optics is the branch of science which deals with light in generation, propagation, and detection, like the difference between sound and acoustics. The word acoustics is more general than the word sound. Also, the word electronics is more general than the word electron. Next. This is the range. This is the range of the light frequency or wavelength. We generally use the wavelength instead of frequency to be easier. You know, if I have a wavelength of 1 micron, it means 3 times 10 to the power 14 hertz. So it is easier to use the wavelength, and accordingly, all books, all reports, all papers, journal papers, and so on, use the wavelength. It is easier. This is the range. We have a part of the light spectrum which is visible, which we can see, and another part is infrared or ultraviolet. This is the range of the light. Next. Why it is late? Why it is late? It really started in 1985. The communications roughly in 1900. So it is late about 85 years. Why? We have two reasons. The first, we don't have single frequency source of light. All of us know the sun, but the sun has a wide spectrum. So it cannot be used as a carrier. You know, we use a carrier with a certain frequency to adjust the tuner in the receiver for this specific frequency. So sun cannot be used. This lasts for 1960, the invention of laser. Laser can be considered a single frequency source of light. So before laser, don't mind anything. After that, we need the light to be guided. You know, if you send a laser beam or a laser ray in a room, for example, in a room, you cannot make the laser cross the wall. How can you cross the wall? It is impossible. How can you go to another building, to another city, to another continent, and so on? It is impossible. So we need to guide the laser in a waveguide. This waveguide is called optical fiber, and it was invented or fabricated in 1966 by Hockham. But in 1966, it was just 10 meters. 10 meters. Now we have thousands of kilometers. Next. This is the spectrum of the sources we know. If you see the sun is wide spectrum, then the monochromatic light is a small bandwidth, but just it is not single frequency. The laser one with cyan light can be considered a single frequency source. Next. As we said, we use the light. It is preferred to be guided, but the scientists stopped here and used the optical fiber. After 20 years, they returned back to send laser without waveguide. How? We will see. So we have two types or two ways of sending light. With a waveguide, which is the most famous, using optical fiber, and without optical fiber, which is called free space optics or FSO. We will see this. Next. Using the optical fiber. What is the optical fiber? Next. The optical fiber is a wire of glass carrying the light or the light carrier. Next. This is the data rate development. I think the resolution is not good, but the communications started with one bit per second, and now with light we reached around 1 terabit per second. 1 terabit per second. Very, very huge bit rate. Next. This is an example of optical fiber communication. It is a transmitter and a receiver. The channel between them is an optical fiber. So what is the optical fiber? Next. These are some advantages. Next. The optical fiber mainly is the core, which is the thin wire inside, which is the core. The core carries the carrier and information, the core itself. It is surrounded by a cladding. After that, we must have some what we call mechanical shielding. You know how can you use a wire with microns dimensions, and how can you deal with it without breaking it? It is a glass, so it needs mechanical shielding. So we put a buffer and a jacket and a coat and everything around the fiber to protect the fiber itself. But the information passes through the core. Next, please. This is the cable in its last form. The yellow ones are the fibers, but the others are just for mechanical shielding to protect the fiber from outside effects. Next, please. In its form under sea, it is like this. Where is the core? Where is the core? It is in the center of this cylinder. It cannot be seen because it is very thin, and the others is just protection. Next, please. This is the spectrum at which we work. We work as you see in the red one. It is not red, but it is infrared. It is with a wavelength 1550 nanometers, which is the best region to carry more information and less losses. Next. These are the bands. As I said, the C band is favorable for the optical fiber communication. Next. This is a 6-minute film, contains everything about the fiber, starting from manufacturing, cabling, putting the amplifier inside the cable itself, putting it in undersea, then to the land point. You see it?
Yes, sir. Yes, sir.
Do you see the video?
Yes, sir. Yes, sir.
Please, do you see the video?
Yes, sir.
Yes, we can see.
Yes, sir. Yes, sir.
Now I will show you 30 seconds film. You can consider it a joke, then I will comment. You see, we are dealing with communications. But if scientists don't know that fish like optical fibers, everything would be destroyed. So they put steel rods inside the cable to protect it from fish. It is a very important information. Again, someone sometimes they tell me, why you show the fish? If you don't know this information, everything will be destroyed. In the land, rats, you know rats? The rats like optical fibers and they cut it. So we put steel rods inside the cable to protect the fiber from rats and from fish. After that, there is 3 revolutions in the optical communications. The first one was in 1990 with the invention of optical amplifier. Why we use optical amplifier? Before this date, we used electronic amplifier, which is electronic, like transistor. It takes long time, which means decreasing the bit rate, and also it is non-linear. We need to amplify the light as it is, the light as a light, without going to electronic domain, to conserve, to maintain the huge bandwidth and bit rate. Next. They invented the amplifier. All of us know that there are 3 places near the transmitter, in line, and near the receiver. The most famous one is erbium doped fiber amplifier. Next. This one, a piece of optical fiber with a length not more than 10 meters, which is yellow one here. This is doped with the element called erbium, which operates at the same wavelength we have chosen before, which is 1550 nanometers, and it amplifies the light as it is without going to the electronic domain. I will show you 20 seconds only, small video to show the idea. 20 seconds. again you will see the light as it is without going to electronic domain. Next, please. Next. Then, like other types of communications, we need to increase the bit rate using time division multiplexing, frequency division multiplexing, and so on. We use the same concepts in optical communications, time division multiplexing, but instead of the word frequency division multiplexing, we use wavelength division multiplexing. Both are the same, but we prefer the word wavelength. Then, how many channels can be put in a single fiber? First, they used one channel, then two channels, then four, and then eight. When they reached 8 channels, they called it DWDM, dense wavelength division multiplexing. Now, in these days, we can put 64 channels in a single fiber. 64 channels in single fiber. A very large information. Next. This is time division multiplexing. Next. Wavelength division multiplexing. Next. This is the dense. You see up 64 channels in single fiber. Like the air. The air carries many channels. Next. This is multiplexing process and the demultiplexing process. For demultiplexing, we need what we call a filter to pass something and returns the other. You will see now. Next. This is called fiber Bragg grating, and it is considered the second revolution in optical communications. It is a very small piece. Stop here, please. This one is a very small piece of the fiber. It can be 1 centimeter long, 1 centimeter only, which has gratings. This is used as a filter to separate the signals from each other, as we will see. Next. Like this. If you have in the transmitter, for example, these wavelengths, which means different colors, you put fiber Bragg grating at the distance you need. Then it returns only one signal and the other pass. Then you return one, reflect one, and the other pass, and so on. So this is called a demultiplexer or a filter. Without it, we couldn't make demultiplexing. Next. Then all of us know what is the fiber to the home. I think most countries in the world have the fiber to the home. In my house here in Alexandria, we have fiber to the home. To the home downstairs, everything is fiber, but to the flats, it is general copper wires, because we don't have in one flat except that we need it, but the complex itself have more information. Next. After these years, the scientists returned back to use light without guide, without a wave guide, without a fiber. This is the third revolution using what we call visible light communication. Visible light communication, VLC. You know, in our houses now, we have a lamp. Our lamps in the ceiling are LED lamps. LED lamps. So the LED is used for illumination, saving more than 70% of energy. 70%. So the LED exists. It is used for illumination. We can use it also in communication, so double functions, which is called VLC or visible light communication. Next, please. Between two buildings or transmitter and receiver, it is called transceiver. So you can send and receive at the same place. Next. Between buildings, but in the roof, between satellites, out. We have no obstacles, so we can ensure that the beam will arrive. Next. These are some advantages, which is very important because we don't need license. Also, no harmful effects for the body health. Not like the RF, not like the radio frequency. The radio frequency is harmful. They say don't use the mobile more time because it heats the head. But using the visible light does not make any health effects. Next. It can be used in the plane. You know, when you ride or you are in the plane, you have a screen on the back of the seat in front of you. All of us, we have screens. We can use a transmitter in the ceiling of the plane and send to all seats. This can be used with visible light communication. Next. Between satellites, as I said, outdoor. Next. Between ships in the sea. Next. We have some challenges, which are, in brief, the weather conditions effects, including rain, fog, dust, and so on. All of these are studied, and I cannot say we overcome everything, but we try to reduce the effect of weather conditions. Next. A small video also.
Lasers are the optical communication of the future. LaserCom demonstration is going to be a 2-year flight. The hardware is made up of avionics boxes that can transmit the data up to optical telescopes that are going to be located on a geosynchronous satellite. The optical telescopes can receive and transmit the data to not only ground stations but to other geosynchronous satellites, low Earth orbit satellites, space station, or in the future, deep space communication missions to Mars. In the fall of 2013, NASA launched a satellite to the moon called LADDI. On that satellite had a single terminal for a demonstration, was supposed to be for only 6 hours, to demonstrate that it could receive and then transmit back a high rate data. And when we talk about high rate data, we're talking about an order of magnitude higher than an RF system can do right now. So that particular program was very successful. It actually operated for 25 hours before the whole thing on purpose was crashed into the moon. So LCRD, Laser Communications Relay Demonstration, is a follow-up program that will have a high-rate data transfer system on a geosynchronous satellite scheduled for 2 years on orbit, but could live as long as 5 years and be used. The benefits of laser and or optical communication is the fact that you can transmit data much, much faster than you can transmit data using an RF frequency device. It'll also carry a lot more data. In both cases, the benefit to NASA is that we can get information out to deep space missions faster, and we can also carry more data at the same time, whether it's a manned mission or a probe, and get that information back. It's more efficient, it's higher data rate, it's just much better.
Next, please. How can we get the lead, which is white lead? We use the word Li-Fi corresponding to Wi-Fi. Wireless fidelity here is light fidelity. So we need the white lead. How can we get a white lead? You will see. Next, please. The white lead can be obtained with the three colors RGB, red, green, blue. All LEDs before 2012 were all colors except the blue one. The blue LED was invented by this Japanese scientist, and he got the Nobel Prize in 2014 because of his invention in 1989. Why he got the Nobel Prize and all others didn't get anything? Because without blue LED, nothing will happen. Next. So the white LED can be used through the three main colors RGB or blue plus phosphorus. I think in your house some of us has white LED. If you carry this lamp, I need you to see what is composed inside it. You will see a blue LED plus a very small piece of phosphorus, which is yellow. Yellow plus blue will get white. This inside the rooms, which is called indoor. Next. The light fidelity corresponding to Wi-Fi, which is a very, very famous expression these days and has many applications. You will see. Next. This is an example using as if the lamp sends information to other devices. Next. We have also a very small video.
Sorry, sir. Your time, 5 minutes more, sir.
Your time is closing?
No, 5 minutes more. 5 minutes more.
5 minutes. So we can move to the other slides instead of the video. Next, please. This is the German scientist, which is Harald Haas. he demonstrated in 2012 the first experiment using the light, the visible light communication. Next. These are the applications. Next. There are many applications outdoor which are between vehicles, which is called intelligent transportation system. Next. When you hear about the car without a driver, this means sensors. All sensors use light or visible light in the streets, as you see. Next. Traffic lights. The traffic lights itself can send information to the riders. Next. The street lights. Next. The road lighting. Next. It is used also in localization. You know the GPS. We can use the light for localization indoor to help blind persons to put his leg in the correct place as if he can see using the visible light communication. It is used as a positioning or localization like GPS, but indoor. Next. In the home, as I told you, in the lamps in the ceiling, you can use the lamps to send information to others. Next. In the hall or seminar halls. Next. But if you need to send to the other room, you need a router. We have also a Wi-Fi router or router which gets from a room and sends to the other room. Next. This is the router. Next. In the aircrafts, I told you it is used. Next. Underwater, it is very important for ROV in underwater applications to communicate between vehicles but undersea. Next. Next. I will finish at the time, inshallah. Next, please. There is an application which is out of communication, and most of us used it in industry, which is called endoscope or fiberscope. Endoscope or fiberscope, to see something without destroying the body. You put the fiber or the fiberscope or the endoscope inside the instrument or inside the human body without cutting it. Like this. Next, this is an industrial endoscope. This person can see everything in the machine without opening it. Next, this huge machine, how can I see inside the machine without destroying it? Putting a fiber. Then the image is transferred to a monitor outside the machine. The same thing in the medical application, see? Next. These are the fiberscopes or medical endoscopes. Next. This is an example to see the stomach of a person without cutting anything. Then the image can be seen outside in a monitor. More of this, the doctor himself can make the surgery in his office using a computer connected to the machines in the fiberscope. Next. Thank you for your time, and again, many thanks for this kind invitation. Next. Next. Greetings from our country to my love country, Indonesia. It has a special place in our hearts, the largest Islamic country in the world, and all persons in this country are kind. Thank you.
Wow, thank you so much. Give applause for Professor Mustafa Hussein Ali Hassan for the great presentation and amazing videos. Okay, so we continue to our next session is a question and answer session. For all the participants, if you have you can raise your hand or write on the comment column of Zoom, say your name and your institution. Does anyone have for this already from the Zoom meeting? Okay. Mr. Isan Ricky.
Assalamualaikum warahmatullahi wabarakatuh. Mr. Mustafa Hussein Ali Hassan. My name is Muhammad Ihsan Rifki. I'm from State Islamic University North Sumatra. I have a question for Mr. Mustafa about pending effect for indoor fiber optic installation. So how do we to resolve this problem to minimize pending effect for indoor fiber communication? And then the second question, how do we find fiber optic broke part in the undersea installation fiber optic. Thank you for your answer, Mr. Mustafa. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir. The first question we have pending. Yes, we cannot put a line which is straight forever. So we have two types of bending. The macro bending, which is outside, it can be neglected, no problem, in condition that we don't reach what they call a critical radius. So it is no problem at all to have a bending. Like the wires, you cannot use a straight wire for hundreds of meters or kilometers. So the macro bending, which is outside, have or has no problem. It is studied many years ago and no problem at all. But the problem is in the micro bending, which is inside the fiber itself, which is called by heating the fiber by the laser. The laser is intense and cause a high temperature inside the fiber. This, in 1987, my PhD, a great part of my PhD was in this point. How can we avoid the micro bending? It depends on many parameters, and everything is studied and is adjusted that the temperature inside the fiber does not exceed 60 degrees. Otherwise, the fiber will be inside having a micro bending, which affects the propagation and cause a very high losses. So we avoid this by adjusting the parameters of laser intensity, laser power, core radius, and so on, to limit the temperature below 60 degrees inside. This is the first question. The second, please, again. Second one, please.
Okay, the second question is how we know
I can't hear.
Hello, Assalamualaikum.
Yes. Yes.
The second question is how do we what we know to any broke part in undersea installation fiber optic. I think what the instrument or parameter we know that the system can make or can a good operation in communication system.
As I understand your question, the undersea, we have a column of water, which is very large. You know, the undersea cables are around 2 kilometers, 2,000 meters at the bottom, 2,000 meters, which is a very large column of water, which cause pressure, and the temperature also changes. We consider the effect of pressure and the effect of temperature in the refractive index of the fiber. You know, everything in the communication of the fiber optics depends on the refractive index. We have Seligman equations, if you know Seligman equations, which calculates the refractive index of the fiber. These equations have the effect of pressure and temperature underwater. You can search for Seligman equations with temperature and pressure. They are considered in our calculations. So if you make all calculations in the land, it is different from making it underwater. Seligman equations. Thank you.
Thank you, Mr. Mustafa.
Okay. Thank you for the answer, sir. Okay, for all the participants, does anyone have a question? Maybe for the one more question.
Halo, Assalamualaikum.
Also to the participant by Zoom. All right, if there is no question, maybe we will give the certificate for Professor Rafika Aliana PhD and certificate for Professor Mustafa Hussein Ali Hassan.
Thank you.
Ladies and gentlemen, thank you very much to all keynote speaker. What a great, excellent research that we very excited about all of your research. Maybe someday we can collaborate in the research or a spicer in our research. Because we are still a young lecturer that should be study hard to be an excellent lecturer, to be an excellent researcher like you all. For the participant in Zoom meeting or streaming YouTube that still have any question, maybe can contact the keynote speakers by email. Finally, me, Rina Widyasari and Bayu say thank you very much for your attention, and we give the next program to our Master of Ceremony, Mrs. Raisa Amanda Putri. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for moderators and the keynote speakers. Today we get a lot of information and knowledge from them. Next session for attendees, please break for prayer and lunch until 1 p.m. and followed by parallel session. For parallel session, will be shared in some breakout rooms at the Zoom meeting. So for all presenters, let's join us again in Zoom meeting at 1 p.m. Thank you.
Thank you, Prof. Mustafa Hussein.
Can I get a copy of this nice picture?
All right, sir. Sorry, sir. Now it's time for break, sir, for Zuhur. Once again, sir. Hello, sir Mustafa. Maybe for now we break for the Zuhur. Thank you so much for this opportunity, sir. Thank you. Assalamualaikum warahmatullahi wabarakatuh.